In this podcast, we're going to talk about percent by mass and molarity, probably the two most abundantly used ways to show concentration in chemistry. Percent by mass is the mass of one substance compared to the mass of the whole solution. Really, there's no difference between percent by mass and percent of anything else. It's always a part over the whole and multiplied by 100. Here's our first example. In order to maintain a sodium chloride concentration similar to ocean water, one must dissolve 1.80 grams of sodium chloride into 50 grams of water. What's the percent by mass of sodium chloride in solution? So what we want to do is take the mass of sodium chloride, which is 1.80 grams, and we're going to divide it by the mass of the total solution. Now remember, if we have 50 grams of water and 1.8 grams of sodium chloride, we need to add those together to get the weight of the total solution. So if I take 1.80 divided by 51.8 grams and multiply by 100, we get 3.47% sodium chloride by mass. Notice that I added the salt and the water together to get the mass of the total solution. The next type of concentration is the most widely used in chemistry and biology, molarity. This is the amount of moles of solute dissolved per liter of solution. I'll start you off with a very simple example. In solution 1, 3 moles of sodium chloride are dissolved in enough water to make a final volume of 500 milliliters. In solution 2, 2 moles of sodium chloride are dissolved in enough water to make a final volume of 300 milliliters. Which has the greater concentration? Well, let's find the molarity of both solutions. In the first situation, we have 3 moles of sodium chloride, and the total volume is 500 milliliters, which we converted into liters, because molarity is moles per liter. So 3 divided by 0.5 is 6. So we would say that's a 6 molar concentrated solution. Solution 2 had 2 moles of sodium chloride dissolved in 300 milliliters. Notice we took the 300 milliliters and made it 0.300 liters. If we take 2 divided by 0.3, you end up getting 6.7 molar. So that means that solution 2 is more concentrated than solution 1 and would have more moles per liter. You should realize that concentration is an intensive physical property, meaning it doesn't matter how much you have of the solution, the concentration will remain the same. Imagine you take a drink out of an entire pitcher of Kool-Aid. Then you pour that Kool-Aid into a small glass, and you take a drink from the glass. They will both taste the same, because the concentration remains the same no matter how much you have. That's an intensive physical property. Here's an example of a typical molarity problem where you're trying to find the molarity of a solution. If you have 10 grams of sodium hydroxide dissolved in solvent to make a 100 milliliter solution, what's the molarity of the solution? So the first thing I remember is that it's moles of solute dissolved per liter of solution, and neither our solute or our solvent are in the right units. So our first thing is to get the grams of sodium hydroxide into moles of sodium hydroxide. We do this by taking the grams divided by the molar mass of sodium hydroxide, which is 40 grams per mole, and we get 0.250 moles of sodium hydroxide. So we have our moles of our solute, and now we divide that by the liters of solution. Well, 100 milliliters of solution is equal to 0.100 liters. If I take 0.25 moles and divide it by 0.1 liters, I get a molarity of 2.50 molar. Here's another example, which I use all the time in order to make a solution. If one wanted to prepare a 1.50 molar solution of sucrose, what mass of sucrose, which is C12H22O11, needs to be added to make a 400 milliliter solution? In order to do this, we take the 1.5 molar, and we need to remember that that means moles per liter. So we say that's 1.50 moles of sucrose per liter of solution. Well, if you look at this and we use dimensional analysis, we know there's 400 milliliters of solution, or 0.4 liters of solution, and you'll notice that the liters will cancel out, and we'll be left with 0.600 moles of sucrose. So in order to make this concentration, we need to have 0.600 moles of sucrose in our 400 milliliters. Well, how do we get moles of sucrose into grams of sucrose? we multiply by the molar mass. We take 0.600 moles of sucrose, multiply by the molar mass, which is 342 grams per mole, and we get 205 grams of sucrose. So in order to make a solution of 1.50 molar sucrose, we need to add 205 grams of sucrose to the beaker, and then add enough water so that the total solution equals 400 milliliters of volume.